Hey everyone, in last video we understood basic Git committing workflow and added a Git commit. In this video we'll be diving into Git branches, but before we do that let's add a couple more Git commits so we have a bit of commit history to work with. So let's add another dummy plan to study programming for data science, and for that we will be adding a folder called programming, under which we will create a text file python.txt, and this is where we'll be tracking our plan to learn core Python along with its packages like NumPy, Pandas, scikit-learn and PyTorch. Okay, and we'll save it. We'll run git status command to do sanity check. As expected, we have some untracked files because we created new programming folder in the workspace which has still not been added to Git's staging layer. We'll do that by running git add dot, and as you can see in the prompt itself that the one file which we created in our workspace has been now added to Git's staging layer. We can confirm that using git status. It gives us the same information that the files which we added in the staging layer can now be committed, and we'll use git commit -m command to make the commit now. Added plan to study Python for data science. Okay, so now that commit has been added, we can clear this and we can run git log to check our commit history. So as we can see, we have added one more commit to our logs. We'll also add plan to study R programming language. So we'll add r.txt, and this will be our plan to learn base R along with its packages like dplyr, shiny and ggplot. We'll save it. So we have saved our file to the workspace. We'll run git status. That will tell us that this is the new untracked file which we can add to our staging layer, and then we can add another commit to send that to our local repository as we discussed in the git committing workflow in the previous video. Added plan to study R for data science. We can clear this. We can run git log to check out our commit history. And as you can see, we have made 3 commits so far. So let's summarize what exactly we have done so far. So we have made 3 linear or sequential commits, one after another. Each commit is uniquely identified by this alphanumeric identifier. And another aspect which is important to remember if you want to form a proper mental model of how Git commits work, along with this unique identifier, Git also has reference to the parent commit. So in this case, for example, you can see our second commit is pointed to the previous commit as its parent, and our third commit is pointed to the previous second commit as its parent. Obviously, our first commit will not have any parent, and this again is important because every commit that you make to your code is basically the changes that you're making to your code relative to your previous commit, which is why it's important to have parent commit as a reference, because it's not recreating the entire code base, it's just saving snapshot of it relative to the previous commit. Now going back to our git log output, one of the things you might have noticed is we have something called head which is pointed to master branch, which is the current branch we are working with, and it's located at our latest commit. You can think of head as a reference pointer which is always pointed to the current branch that we are working with, and it's pointed at the commit which defines the state of code that we are currently working with. By default, that commit will always be your latest commit, as we can see here, right? But you can always travel through your commits. That's the point of maintaining a history of commits, and every commit having a reference to the parent, meaning you can actually travel back to your previous states of code. For example, in this case, if we decide that before we even start learning R, we want to maybe learn one of the cloud skills, then you can just move your head to your second commit where we have not yet added r.txt, and then you can start working from there. And the way we do that is we copy this commit identifier for our second commit, and then we use this command git checkout to our commit identifier. We'll discuss this comment later. All it is telling us is that we have now switched to that particular commit. Let us again run git log. As we can see, we now have 2 commits that are showing up with our head pointed to the second commit. We can even use git log all to make sure we have all the commits shown up. So we have our first commit, we have our second commit, which is where our head is located. So that is what will define our current state of code, and not the third commit, which is our latest commit. And because our current state of code is defined by second commit, you can now see that we don't have r.txt available because we added it to our third commit and then we have traveled back to our second commit. Okay, so before we start adding our plan to study cloud skills, let's spend some time thinking through what we are about to do here. Our head is currently pointed to our second commit, which will define our current code, and any more changes we add here will now be added in a sequence to that commit, which also means we no longer will be on the same linear sequence that defines our master branch. So we have implicitly started creating our new branch the moment we add commits from this point. In this case, it's just better to explicitly create a new branch, and that is what Git is warning us in this comment, right? So it's telling us that you are in a detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches by switching back to a branch. If you want to create a new branch to retain commits you create, you may do so now or later, but the problem is if we do it later, it will just involve us being more careful. So we might as well just add a new branch now. So this is where we're creating our first new branch using this command, git branch, and then the name of our branch. But before we do that, I always like to do a sanity check before I create a new branch, just to take stock of what branches I currently have and what branch I'm currently creating the new branch of. So we can use this command, git branch, and it is telling us that you have one branch master and you have not another branch, but you have your head, which is currently in detached state, pointed at this particular commit. So let us now create a new branch using git branch. We'll name our branch as feature / and in this case we'll just have cloud plan as our branch name. Now there is always a naming convention for your branch. For example, it should never have any spaces. Git won't allow that, and then the company that you're working for will also have its own naming convention that you have to abide by. Your branch name should always tell what feature it is that you're working on, and in this case we'll just keep it like so. Create a new branch. Now let us again run git branch to check our current state of branches. As you can see, we have our master branch and we created a new branch which is feature cloud plan, and then our current code is basically defined by detached head, which is not a branch. It is just that our head is pointed to our second commit. Let us also run git log all, and that is also giving us the same information. We have our master branch, we have our detached head which is pointed at the second commit, and we created a new feature cloud plan which will be created off head from the second commit. So you have to remember that anytime you're creating a new branch, it always gets created from the commit where your head is pointed at. So before we start making changes, we should always be mindful as to which branch is currently active. You can see in this output of git branch, it's not our feature cloud plan branch which is currently active, but rather it's our detached head which has this asterisk associated with it. You can also glean the same information from git log command. Even though our head and our feature cloud plan are still pointed at the same commit, we want our head also to point at feature cloud plan. If you remember one of our previous git log outputs, in this case when we were only working with master branch, we have our head pointed to the master branch, and this is what we want in this case also, our head to be pointed at feature cloud plan, and that is where we have to switch to our feature cloud plan branch after we create it using git branch command. That switching we can do using this command, git switch, and the name of our branch which is feature / cloud plan. It's confirming that we have indeed switched to our branch. Let us confirm that by using git branch command. You can see it's our feature cloud plan branch which is currently active. We can also run git log command. See, now we have what we wanted. Our head is pointed at the feature cloud plan, and whatever changes we make now will be the changes which will be included in the feature cloud plan, and it will be a different splinter or different branch from our previously created branch which is master. So let us start adding our plan to study cloud skills. So we can just create a new folder, cloud skills. We can add azure.txt, and this is where we'll track our plan to learn Azure and its services. We have sure that we have added everything we needed to, so we can just run git status to do a sanity check. So you can see we have some untracked files. We can then add those files to our staging layer, run git status to confirm it has indeed been added to staging layer, and then we can now run git commit to add our changes to the repository. So now that we have added our plan to study cloud skills, let us get back to learning R. So we will be creating r.txt like we did in master branch, except this is the one that will be created in our feature cloud plan branch. And this is where we will be tracking our plan to learn core R and its powerful packages, dplyr, ggplot and shiny. We'll also add that R is better statistical analysis language than Python. We'll save it. We'll also add one more line in our plan to study Python, that Python is better general purpose and machine learning programming language than R. And then we will run git status. So interestingly, this time our output from git status is a bit more involved. So obviously we have an untracked file in r.txt which we newly added, and we also have another file which Git was already tracking, which we have now modified, python.txt. We can add both of these changes, the newly added file as well as a modified file, to our staging layer. As you can see from the prompt also, we have added a new file and we have also modified a file which we already had. At this point we can just add our commit, added plan to study R for data science. Okay, and we can again run git status for sanity check. We are on branch feature cloud plan and there is nothing to commit. Our working tree is clean, meaning everything that we already saved to our local workspace has been committed to local Git repository. Before we end this video, let's visually summarize what we did so far. We started with our first commit from the master branch. As you can see, our head is pointed to our master branch on our first commit. Then we went ahead and created another commit, and as we keep making commits, both our master branch as well as the head will keep on moving with it. We made another commit, and this is the point we realized that before we start learning another programming language in R, we want to learn one of the cloud skills. So we ended up moving our head to the second commit. At this point our head is in the detached state, so when we went ahead and created a new branch, it's pointing at the same commit that our head is pointing to. It's still important we switch to our new branch before we start making any changes. So we switch our head, which is now pointing to our new feature branch, and then we start adding our plan to learn Azure. And as you can see, our feature branch as well as the head keep moving along with our new commits. We add our plan to study our programming language. So this is the current state of our code base, where we had our master branch that we began with, and then we splintered a new feature branch from it to make some changes which are independent of our master branch. This essentially is what Git branching is super useful for in a team where you have multiple data scientists and machine learning engineers who are working from the same code base. You want this ability to have multiple parallel contexts that each team member can work with without disturbing each other's code. So whatever changes you make in the feature branch here will only work within the context of that new feature branch, and it will not affect any other branches. We can also visualize Git branching using Git Lens. So remember, Git Lens was a GUI client extension which we installed a few videos back. So you can just go to Git Lens, and that is where you'll be seeing a view like this. You had your first commit here, you had your second commit here, and then you moved on to the third commit on the master branch. Then we moved back to second commit, and at this point we created a new feature branch. We added 2 more commits in that feature branch. You can also have a branching view from command line. You can use git log, but you'll have to use more flags with it to get the full branching view. You can use graph, decorate, and we can also use one line to make sure that we don't get too many details in our logs. It's telling us that you had your first commit here, you had your second commit here, then you added this commit while you were on the master branch, then we moved back to second commit from where we created a new branch. We added another commit on that new feature branch to learn Azure, and then we added another commit to study R. Our head is currently pointed to the feature branch. So this might be more difficult to visualize on the command line. Usually I always use Git Lens if I want to get any visual view of how many branches there are and which branch I'm currently on. So that's it for this video. In the next video we'll be learning how to merge Git branches and how to push our code to GitHub, which is a remote repository connected to our local repository.